So what we're going to do today is we're going to be finding limits graphically, okay? Now we did some limit stuff last year in Honors Math 3, okay? And so I want to go back through this and what does this mean, okay? And we're going to talk first about one-sided limits, okay? So if you recall, if we see the limit as x approaches c and this positive, okay, this means from the right, okay? So as x approaches C from the right, f of x approaches this number that we're calling L. Okay, and that's how we read it, okay? So this is, we can tell that it's approaching from the right because C plus, right? With the plus is in the little exponent. And I know the resolution on this might not be the best and you can't see the plus, okay? But that should be a plus right there, okay? You're gonna see it on your assignments, okay? Now, over here on this one, this is called a left-hand limit from last year, okay? And that's where x is approaching C and we have a little negative, so that means to the left of C, okay? So as x approaches C from the left. So we start on the left side of it, okay? And then what this statement is saying, f of x approaches some number L, okay? All right. So looking at this, okay, for this one right here, I want to look, what is the limit as x approaches 5? So we write lim. Under the lim, we write x with a right arrow. And I want to approach 5. Okay, so I want to approach this value right here, okay? So I want to approach 5 from the right-hand side, okay? So that means along the graph, I'm going to have to come along the graph until I get to this point right here, okay? So I'm coming along the graph, and then I'm going to read it right there, okay? So what's happening right here, okay? So because my x is approaching 5, but I'm approaching 5 from the right, okay? So that means the limit as x approaches 5 from the right, f of x. And if we read this, we can read it as -3. So this is equal to -3. Okay, so we got to start on the right side of 5 and then go along the graph, kind of like you're an ant and you're walking along the graph. And what is the ant thinking he's going to get to as the ant gets closer and closer to 5? It's thinking on the graph, it's going to get closer and closer to this number -3. Okay. Now on this one, okay, we're going to do the same thing. We're going to, but we're going to approach it from the left-hand side. So this would be the limit as x still approaches 5, but from the left of f of x. And what does that equal? So if we start over here to the left of 5 and we walk along the graph, right? We walk along the graph until we reach 5, we reach this value of -3 again, right? Okay, so the right-hand limit is -3 and the left-hand limit is -3, okay? And here we go, okay? So what is the definition of a limit, okay? So here's the definition of a limit. And this is like the first calculus lesson, okay? The definition of a limit, now this is kind of an informal definition, okay? A function f of x has a limit x approaches c if and only if, okay? So these are the conditions that have to be met. The right-hand and left-hand limits at c exist, so they have to exist. You're gonna see some that don't exist in a little bit. And they are equal, okay? So this is gonna be true. We say this limit as x approaches c of f of x equals L if and only if the right-hand limit and the left-hand limit are equal to the same number. So in this case that we just did, they are, right? So what does that mean? That means the limit as x approaches the number 5, f of x is equal to -3. Now, why? So here's the why. Because f of, sorry, not f of x. Let me get white out. Let me get some white out. Okay, so here we go. It's because, and I whited this out right here, okay? It's because the limit as x approaches 5 from the left of f of x equals -3, and the limit as x approaches 5 from the right of f of x equals -3. They're both equal to -3, okay? And that's it. If they don't equal each other, the limit doesn't exist, okay? All right, so let's go to the next one. To help you better understand this idea of one-sided limits and the definition of a limit, okay, I want to show you a little bit of an animation, okay? So right here, this is the function value at a, and in this case, a is 3, okay? And over here, it's saying that f of 3, because a is 3, f of 3 is equal to 1, okay? And that kind of makes sense because right between 0.5 and 1.5, that'd be 1 for the y value, okay? Now, open dot here, okay, and watch what happens. Okay, so this is saying the limit as x approaches a, and we have a little negative where the exponent would be, right? And what that means is we're approaching the value of a from the left, okay, from the left. So if we look at this, okay, see how a point on this curve from as x approaches 3 from the left, the y value is getting closer and closer to 3. And that's why this comes out to be 3, okay? All right, now let's do from the right. So let's come from the right side of 3. So you see x is left on the left-hand side, right? We start to the left of it, and we're coming towards it, and we're looking at what the y value does. Okay, how about from the right? So from the right, it's approaching the value of 4, okay? So as x approaches 3 from the right, the function value is getting closer and closer to being 4. So on the right side, it's approaching this open dot. On the left side, it's approaching this open dot, and they're different, right? So we would say the limit doesn't exist because they're not the same, okay? This is going to come up time and time again. The two limits, okay, the two one-sided limits have to be the same, okay? Okay, so on this problem right here, okay, we want to find the f of 2. Now, what is f of 2? That means the actual function value. That has nothing to do with limits, okay? So f of 2, we look right here, okay, f of 2, and we read it, and it looks like it's -3. So f of 2 is equal to -3, okay? Now, what is this one saying? This is a left-hand limit because it's because of the negative right here. That's what we're going to start on the left side of 2. So if we start from the left side of 2, we read this and we can tell that it's going to approach -3. Okay, so we're approaching this way, right? And so we see that it's approaching -3. So f of 2 from the left is equal to -3. Okay, and then from the right, that's what this next one is. From the right, we're going to come in this way, and we can tell that it is -3 also. And now, okay, we know that those two, since those two are the same, we know this one is equal to -3, okay? And that's how you do it, all right? That's how you do it graphically. Okay, so for this next one, okay, I'm asking you to find f of 4. So we go 4, and if we look, there's an open dot right here, okay? Now, what does an open dot mean? That means that it doesn't exist, okay? We'd have to have a closed dot for it to exist. Remember that from last year, okay? So what does this mean? And there's no other point, so that means f of 4 does not exist. You're going to see on Delta Math, it says DNE, okay? And that stands for does not exist, all right? Okay, so how about this next one? This is saying the limit as x approaches 4 from the left. So we're going to approach 4 from the left-hand side. So that'd be going this way. Okay, now the function doesn't exist, but we are getting closer and closer to that open dot, right? And so what it means is that that's going to be the left-hand limit. It's going to be the limit as x approaches 4 from the left is equal to 5. Okay, how about from the right? So from the right, it's crawling along this parabola, right? And as we approach it from the right, we are also getting closer and closer to that open dot, right? And that open dot is at 5. So the limit as x approaches 4 from the right of f of x is equal to 5. And those two are the same. Therefore, the limit as x approaches 4 of f of x is 5. Okay? Okay, so for this next one, I'm asking you to find f of 3. Okay, so we start at 3 and we look and we go towards our graph, and here's an open dot. So it's not that one because remember that doesn't include it. But right above it, we do have a dot, right? So f of 3 is actually 6 here, okay? So this is equal to 6. Okay, it's where the open dot is, and if there's no, I'm sorry, it's where the closed dot is. That's the function value. If there's no closed dot, the function doesn't have a value, okay? All right, so the next one, how about as we approach 3 from the left? So as we approach 3 from the left, we'd be on this side of 3, and we'd be approaching this open dot, right? So what's that open dot at? Well, that's open dot is at 2. So this would be 2. All right. How about as we approach 3 from the right? As we approach 3 from the right, we're going to be to the right of 3, coming towards 3. Okay. And then it's approaching that open dot, right? And that open dot is 2. These are both equal to 2. All right. So the limit as x approaches 3 of f of x is equal to 2. Now, so up to this point, they've all existed, right? And because we've gotten these two limits and they turn out to be the same. Well, let me show you some examples of where the limit doesn't exist because these two they're not the same value or they don't even exist, okay? And that's what the next examples are about. All right, so here we want to find f of -3. So f of -3, we go to -3 and we go towards our graph to the closed dot, and it's right here, okay? It's not this one, that's an open dot. That means we're not including. This one we're including, so this would be 3, okay? So f of -3 is 3, okay? So what's the limit as x approaches -3 from the left, okay? So as we approach -3 from the left, that'd be to the left of this -3. So we're going to start somewhere to the left of it on the graph and go along the graph, and it's getting closer and closer to that closed dot, right? And that closed dot is at 3. So this is 3. Okay. Now, how about -3 from the right? So we want to be to the right of -3 along the graph and then follow along. And this side is approaching the open dot, right? And that open dot is at 1. So this is 1. Okay. And what that means is that the limit as x approaches -3 of f of x does not exist. And why? Because those aren't the same. Okay. You're going to see people write DNE for does not exist. And that's absolutely fine. Okay. Okay, so for this next example, okay, this is the graph. I should tell you this. This is the graph of y equals tan of x. Okay. And if you look at this, okay, f of pi over 2, okay, f of pi over 2, well, if you go start at pi over 2, it doesn't exist, right? This is getting closer and closer. Remember, that's called a vertical asymptote, okay? So f of pi over 2 doesn't exist, okay? So this one does not exist. Okay, as x approaches pi over 2 from the left, okay, so we're going to be to the left of pi over 2. And if you look, our graph just shoots up like crazy, right? Okay, so when that happens, this one, and we did these last year, okay? Not with trig, but we did it with rational functions, okay? When it shoots up like that, when it explodes, that means it's going towards infinity. Now, I want to say this. When a limit, one-sided limit or a limit is infinity, that still does not exist, okay? So this describes it, but for a limit to exist, it has to be a number value. That's not a number value. That's just describing the behavior of this, okay? Now, how about the limit as x approaches pi over 2 from the right? So we have to be to the right of pi over 2. Well, that'd be somewhere over here. And we'd be exploding down on this one, okay? So what does that mean? That means this one is equal to negative infinity. It's going down in the negative direction towards infinity, okay? Now, this one, okay, because these don't agree, and also because they're both infinities, right, this does not exist. Okay, now, even if these were both infinity or both negative infinity, it still would not exist. We could, if they were both the same type of infinity, we could put positive infinity or negative infinity, okay, if they were the same. We could write that here, but whenever a limit is equal to infinity or negative infinity, it still does not exist, okay? I'm going to write that. Because it's not approaching a number value. Okay, so whether it's infinity or negative infinity, okay, it does not exist, okay? All right, last problem we have. Okay, now this graph is hard to read, okay? And the reason it's hard to read is it's bouncing around. Okay, so look right here, it's above the x-axis, right? And just a little bit later, it's below. And then it's above and it's below. That's why this is really dark and shaded in here, okay? It's because you just go a little bit to the left or to the right and you're above the x-axis, then you're below, and it's bouncing above and below the x-axis, and it's not getting closer and closer to anything, okay? Which means we can't even tell what this is equal to, okay? So f of 0 does not exist. I don't think you're going to see any on delta math of this type, but you might, okay? The limit as x approaches 0 from the left does not exist because it's just bouncing around. It's not getting closer and closer to any one value. It's just going, sometimes it's positive, sometimes it's negative, okay? So this does not exist. You're going to see when we go to tables, we're going to do one like this, and you're going to see why it's bouncing around. And it's like, okay, I see why it doesn't exist, okay? That's next week's lesson, okay? How about the limit as x approaches 0 from the right? Well, from the right, it's just bouncing up and down, okay? So this one does not exist. Okay, and then the limit, well, neither one of these exists. So this one can't exist if these aren't the same. So this one, we say it does not exist. Okay, and so that's how we do limits graphically. I'm really hoping that this is fairly an easy assignment for you guys. And I'll tell, okay, if you go to Delta Math and I can see, like, if you're getting them all right, that's a good thing, okay? I'm hoping that happens, okay? All right, that's it for today.